Live. So good morning or good afternoon, depending on where you're joining us from, everyone. My name is Jesse, and I am with Exploring by the Seat of Your Pants. For those joining for the first time, and we do have a few classes joining for the first time today, we are all about bringing conservation, adventure, and science into classrooms around the world. And we are particularly excited because February for us means an entire month dedicated to showcasing the world's most amazing women in science and exploration. Over 45 sessions bringing in incredible women from I think 20 countries, every continent in the world this month. So it's a crazy month. Thank you so much for joining us for the festivities. So right now we're joined by 6 classes from across North America. I'm going to give them a chance to say hi before we dive in. So we've got Mr. Smith's grade 5/6s in Anchorage in Alaska. Hi, guys. Hello. Hey, welcome in. We've got Miss McDonough's grade 4s in Leesburg in Virginia. Hi, guys. Hey, there's so many of you, and you're so excited you broke the mic on your thing. It's on, but we can't hear you. That's how loud you were. Well, way to go. We've got Miss Hewitt's grade 6s in Burlington in Ontario. Hi, guys. Hey, awesome. We've got Miss Terklassen's grade 6s in Kitchener. Hi, guys, Ontario. Welcome in. I like your semicircle plan. That was very well done. We've got Miss Vitito's grade 6 through 8s in Augusta in Kansas. Hi, guys. Oh, let's get them. Let's see their mic. Hey, the mic didn't want to work for a second, but you're there and you're excited. And last but not least, we've got the old group here, Miss Digby's grade 12s in Fairfax in Virginia. Hi, guys. Welcome in. Other mic now. We got all the mics not working for us. That's okay. It keeps it interesting. So the reason you guys are all here today is for our speaker. So we are joined live in Pasadena, California, where we all wish we were right now in the middle of winter, by Dr. Abigail Fraeman. So she is the Deputy Project Scientist for the Curiosity Mars Rover and Research Scientist at NASA's Jet Propulsion Laboratory. So this is one of the most iconic and storied research facilities in the entire world. They literally put robots on other planets, and Abigail has the opportunity to see things before anyone else in the world gets to see them as we explore our solar system. And if there's a cooler job than that, I don't know what it is, but we're going to dive in with Abigail, learn a little bit about what she gets to do. We're so happy to have you back, Abigail. And without further ado, take it away.
Oh, awesome. Thank you so much. I'm so excited to be here. It seems like we have a really great group on. So yeah, I'll start off. I'll tell you guys a little bit about what I do and how I got here and show you some pictures, and then looking forward to hearing all of your questions. So I will go ahead and share my screen to show my photos.
Perfect.
Can you see the sharing? Great. I'm going to close this. Well, see if we can move that down. Awesome. All right. So yeah, I'm going to talk to you today about the job that I get to do, which is exploring Mars. So this is where I'm talking to you from right now. This is my office. I work at NASA's Jet Propulsion Laboratory, which is located in Pasadena, which is a town right south of Los Angeles in the United States in California. Jet Propulsion Lab, or as we call it, JPL, is a really exciting place to work. And it's beautiful, you know, being in California. You can see actually today looks something like this. There's some mountains behind us. Sometimes they get snowy. And it's a campus of about 5,000 or 6,000 people who work here. There's people like me who are scientists, but there's also people who are engineers. There's people who are science communicators, journalists, lawyers, business people. All sorts of people work here, not just scientists and engineers. It might be a little bit confusing to say I work for NASA, but I also work for JPL. It turns out JPL is actually one of several different centers that make up NASA around the United States. So, you know, I'm circled out here in red in California. Some of the other NASA centers you might be really familiar with include the Johnson Space Center in Houston. They're the center that's in charge of all of the astronauts. So you might be familiar, you know, Houston, we've had a problem. That was the astronauts talking to Johnson in Houston. All of the rocket launches, or many of them, happen out of Kennedy Space Center down in Florida. I know a couple of you guys are from Virginia. There are some NASA centers up in the Virginia, DC, Maryland area, including NASA headquarters in DC and Langley Research Center. And each of these different centers specializes in something a little bit different. So us here at JPL specialize in robotic exploration of the solar system. So that is building orbiters and rovers to explore all of the different planets robotically. So we don't do anything with astronauts or humans. We're all roboticists. A little bit about my work in particular, I'm interested in exploring the whole solar system, but I have a real special affection for exploring Mars. And this is really my field site. Why am I interested in Mars? Well, first of all, Mars is a really exciting place because we think it has the potential to help us answer one of the biggest questions that we have as a human species, which is, are we alone in the universe? Mars today is very cold. Its atmosphere is very, very thin. There's no liquid water on the surface. So if you were to go to Mars, it'd be really hard for you to survive. You need to bring a spacesuit with you. You need to bring a lot of water with you. You need to bring something warm to wrap yourself in. But we think billions of years ago, Mars was probably a lot more similar to Earth. It was probably a lot warmer. We now know that there had been liquid water on the surface. It probably had a much thicker atmosphere. And we actually think that Mars and Earth were so similar 3-4 billion years ago that we wonder if the process that formed life on Earth may have also happened on Mars. And so we want to go to Mars to look for evidence of whether or not there could have been life on that planet. Of course, if we find evidence of that, that's like a huge game-changing discovery, because it would show that life could arise independently twice in 2 planets in one solar system. And if you think about all of the thousands of planets we've now found orbiting other stars, that really tells you that the probability that there's life elsewhere in the universe is huge. But we haven't found life on Mars yet, but we're still looking. I think Mars is also really exciting because it helps us understand how planets work in general. As I said, Mars a long time ago was very different. It was a lot warmer, wetter, a place life could have lived. And today it's very cold and dry. And so what are the factors that govern that changing climate? What made Earth a really good place to live? And what makes places like Mars or other planets in our solar system like Venus, what makes them so different from Earth and places that life couldn't live today? So we can go to Mars to study to understand that question. And again, that's an important question because it helps us understand now all these planets we're finding, thousands and thousands. What are the factors that might make them evolve into something nice and Earth-like or something a lot more inhospitable like Mars? And Mars is also really exciting because it's a place we could actually go. Somewhere like Venus, you couldn't send a human there. It'd be way too hot and too much pressure from the atmosphere. But Mars is a place that we think humans could go, we could visit, we could study. And isn't that cool to think about sending humans to Mars? So before we do that, we need to understand, what might a human encounter when they get to Mars? What are sort of the challenges they might face? And we can prepare and we can think about how we can overcome those challenges. So studying Mars is important to help us prepare for sending humans to Mars. And, hopefully that will be in the next decades. And maybe some of you will get the trip to go to Mars. I think that would be really cool. So how do I study these things about Mars? How do I answer these questions? Well, I approach it the same way a geologist does. I am a geologist. On Earth, we can do geology. We can look at the rocks and we can use them as clues to understand what places were like millions, and on Mars's case, billions of years ago. We can go out into the field, we can look at what the rocks are made of, we can look at what they look like, and all of them are kind of clues that are pointing towards the evidence of what happened a long time ago. Here's some pictures of me getting to do geology in some very Mars-like places on Earth, out in the desert where it's very dry. The middle picture is actually me in Iceland, which I think is one of the most Mars-like places on Earth, just because the rocks are made of the same stuff and it's got a similar really cold and icy climate. And then also studying some sandstones in the American Southwest. Now, doing geology on Mars is a little bit different than doing geology on Earth. Instead of being able to walk out to your rocks with your rock hammer and, pounding on the rocks and breaking them open, we can't do that on Mars. So instead, we send our fleet of robots to do geology for us. Here's a picture showing some of the orbiters that we've sent to Mars since the 70s. We've sent a fleet of orbiters to Mars since the 70s that have been taking pictures of the surface, that have been getting us information about the composition of the planet, what the rocks are made of, live, where there's water ice, all sorts of amazing things. Here's an example of one of the pictures that came down from one of our orbiters called the Mars Reconnaissance Orbiter. And these are rocks on Mars that have these amazing layers that are just layers on layers on layers. And in between these layered rocks, there's these beautiful sand ripples coming in. Here's another picture just showing an amazing ripple field of this black sand that we see that covers all of Mars. And here's a very special place on Mars that is an image of the part of a rim of a crater. You can just see the crater rim here, and feeding into this crater rim is this big channel that ends in this really funny looking feature that we actually think is the remnants of something called a delta. Which means there was probably once a river that flowed into this crater, and within the crater was a lake. And when the river reached the lake, that's what formed the delta. We can also use the orbiters to figure out what the crust is made of. So all of the different colors in this image, those colors show the sorts of rocks and minerals that are there on the surface. And we see that the rocks and the minerals that are there are the kinds of minerals that form when you have water. So we think this was a very special, once wet and watery place. And this is a site called Jezero Crater. And remember this because I'm going to get back to this at the end of the presentation. But what I specialize in addition to the orbiters, are rovers, which are spacecraft that we send to the surface of the planet. They can make really detailed measurements, up to the millimeter of the rocks and what they're made of and what their textures are. This is a picture of the first rover that I got to work with. It was named Opportunity. There were actually two rovers that were twins, Opportunity and Spirit. Those landed in Mars in 2004. They were supposed to last for only 3 months, but Opportunity lasted all the way until we declared the mission over last year in 2019. So, for a pretty good span for a 3-month mission to last years and years and years. I'm going to talk about Opportunity because it's very special in my career path because it's really the rover that inspired me. This was the view of Mars that we had before Opportunity landed. It was this very red, rocky place, lots of dust every year, dust everywhere. But the picture that Opportunity sent back when it first landed looked like this. And this was just such a totally new and different view of Mars. And it just kind of blew my mind. You see these really dark sands, and then you see this light colored, what's called bedrock sticking out of the sand. And I actually was an 11th grade student. So I was some of your ages, I was 16. And I got to come out to JPL as part of an outreach program. And I was actually in the mission control room when this picture first came down. And that's a picture of me seeing it for the first time. And I was just so excited because this really showed me that, we're exploring. Here's a totally new thing that no one's seen before. And then being in that room, I was also surrounded by a bunch of scientists who, they saw this image and they were like, that looks totally different. But they were also excited because they recognized that was bedrock in the wall. And bedrock to geologists is gold. It's rock that's formed in place and tells you so much about the history of the planet. And so they're jumping around screaming, there's bedrock. We found bedrock for the first time ever. And, I wanted to know what that meant. And I wanted to have a job like them where I got to be so excited and understand how to read images like this. And that's what sent me on the path to become a planetary scientist. Here's actually my career path laid out along the whole traverse of Opportunity. It gives you how long this mission lasted. And so this is the way that Opportunity drove. And up here is when it landed in that site called Eagle Crater back in 2004. Again, I was a junior in high school. I went on to graduate high school. I went to college where I studied physics and geology. I did some summer research internships at university working with the rover. After graduation, I went off to graduate school. I studied Earth and planetary science. As a graduate student, I became involved with the Opportunity mission, picked up a master's degree, got my PhD, moved to California where I started a position called a postdoc at Caltech. And then I was eventually hired by JPL, where I started as a research scientist. And about 2 years before the end of Opportunity's mission, I was actually appointed the deputy project scientist of that mission. So was deeply embedded in the team in that point, and I served in that role until the mission ended. So it's just a summary of my career, and also a show of how long this mission lasted. But right now, I am now the deputy project scientist of another rover called the Curiosity rover. And I'm going to stop sharing for just a second to show you. This is a model we have of Curiosity. It's a very special rover. It has an arm that we can use to look at rocks. There's actually an instrument on the arm that was built by Canada. So those of you listening in Canada, we have a bunch of Canadians on our team working on that instrument. We have a bunch of cameras on the mast. We have a laser on the mast. It's powered by nuclear power in the back. You know, and I'll say that this is not a full-size model of Curiosity. I wanted to bring a full-size model, but unfortunately it couldn't fit. So instead, if you take a look, this is the wheel on the model. I do have a full-size wheel for you. This is what a wheel, the size of the wheel for the rover is. So it's quite a big rover, and you can see why I couldn't bring the whole thing in to show you guys.
That was great.
Here's a picture of what Curiosity looks like to scale with people. And then here's also a scale of Spirit and Opportunity, and then a teeny tiny rover. That's the Pathfinder rover, the first rover we sent to Mars. So you can see how big it is. We sent Curiosity to this big crater on Mars called Gale Crater that has a giant mountain in the middle of it. That's named Mount Sharp. Here's what Mount Sharp looked like when we landed. We couldn't land on the mountain because it was too steep, so we landed on the plains next to the mountain. From orbit, we'd seen that there were layers in the mountain, and we wanted to learn what made those layers. These are the sorts of rocks we saw right when we landed, and you can see there's these kind of rounded pebbles all embedded in them. You know, maybe they look like a chunk of concrete. They're actually a kind of rock called a conglomerate. And we see really similar rocks that form in rivers and streams here on Earth. So we were able to tell that there was once a river coming into this area. When we spied the mountain in the distance, we could see that it was still really finely layered. And when we finally got up close to those layers, we saw that there was even finer layering. And it was this really fine-grained, really parallel layered rocks. So integrating all of this, we were able to come up with a model that sometime probably 3.5 or 3 billion years ago, there was once a lake that came into the crater and filled the whole crater, sorry, a river that came into the crater and filled the whole crater with a lake. And looking at what the rocks are made of, we think this lake was probably made of water that was really drinkable. This was probably a place that if you had put life in when the lake was around, it could have thrived. So we found that Mars once had environments in the past that were habitable. We still don't know if they were inhabited, but we know that it supported environments that could have supported life. Here are some pictures that are, you know, where we are right now, hot off the press, what the rover's doing right at this very, very minute. We just drilled an area that we called Hutton. So here's an animation of our arm drilling into the rock. We collected this teeny tiny amount of drill powder, and we put it into the interior instruments, and we analyzed their chemistry and got some really detailed measurements. We're also seeing some really cool, weird looking rocks that are probably reflecting water that interacted with these rocks at some point, and then wind later came and carved them into these really cool wonky shapes. And then I'll end by just giving a preview that we have another rover launching to Mars in 2020. These are pictures that I took in the building right behind my office where they were building the rover. It doesn't have a name yet. Right now it's just called Mars 2020, but they'll be announcing a name soon. And this is what it looked like just a few weeks ago when they were building the rover. It looks a lot like Curiosity. It has a big difference that on its arm, it actually has an instrument that's going to be able to collect little tubes of rocks that we might be able to pick up at some later point and send them back to Earth. But it was really cool to see them build this rover. They just boxed it off and shipped it down to Florida. And again, it's going to launch in a few months. And it's going to go to that very special site that I showed you earlier, that Jezero crater site with a big delta and the lake in the middle. So it's going to study another site that we think may have been a really good place that life could have lived. And by starting the process of collecting samples that we might bring back to Earth one day, we're actually, I think, going to make the best effort we're ever going to make to look for evidence of life in these rocks. So that's a very exciting mission. So stay tuned. Launching in July, landing in February of 2021. And then I'll just leave this slide up for a little bit. If you're interested in following along with Curiosity, you can actually follow along real time. We blog every day when we do operations of the rover, so you can read what we're up to every single day. And then all of our raw images are posted online. Basically, as soon as we see them, you can see them too. So anyone, anywhere in the world can access our data. So if you're interested, please follow along. And so that's all the slides I had to share for you guys, and I'm looking forward to taking questions.
Super cool. I am hopelessly biased. We do so many space stations, and you literally are my favorite person we bring in for this, so I'm so happy to have you back. How many people have a picture of themselves when they discovered what they wanted to do, like the moment where it's like, oh, yes, so cool. All right, in addition to our live classes, and I'll come to you guys in a second, we've got a bunch of groups watching on YouTube Live. If you guys want to let me know where you're joining from, what grade you're in, I'll take as many questions as we can on YouTube as well, so don't be shy. But that said, let's kick off by going to Mr. Smith's class. If you guys want to come up, go for it.
Hello, I am so excited to have you here. Thank you so much for joining us. And I want one of the questions from one of my students, I actually have seen all the documentaries about it, and I think they would like to know, what would you do if the robot got stuck?
Oh, that's a great question. That actually happens. Sometimes our rovers get stuck in the sand. It happened with Curiosity in a place called Hidden Valley. We drove into a really sandy filled valley, basically, and we found that we were getting something like 90% slip of the wheel. So we were just spinning and spinning and spinning. In that case, we were fortunate that we were able to back ourselves out. It took a couple drives, but we were able to back ourselves out. Opportunity got stuck as well. The Spirit rover actually got stuck in the side of a crater, and we weren't able to extract it. We did a lot of testing here on Earth to try and figure out what's the best way to get this rover unstuck. You know, the worst thing you can do is if you get stuck in the sand, do something that makes it worse. So we did a lot of testing here on Earth. Unfortunately, we weren't able to figure out how to get it unstuck. And so that's actually what ended the mission. We got stuck with the solar panels tilted away from the sun, and we just weren't able to get enough energy to keep it going through the winter. But we try very hard not to get the rover stuck. And this is actually one of my roles on Curiosity, is to work with the engineers who are actually driving the rover to assess the types of terrain we're driving into, and using my knowledge of the geologic properties of the surface to talk about whether or not we think it'll get stuck. There's a whole field of study about interaction of vehicles in the terrain called terra mechanics. So if that's something you're interested in, it's something you can study and work on.
Cool. Thanks so much, Abigail. All right, let's head to Miss McDonough's class. If you guys have a question, come on up.
Ew. Can you hear us?
Yes.
Oh, good. All right, Gabby, look right up there and ask your question.
What are rovers made of?
Ooh, what are rovers made of? All sorts of different stuff. So the wheels are made of aluminum. It's really strong and really light. A lot of different pieces on the rover are made of, I think, aluminum. Sometimes we have to use special metals based on the properties they have of conducting heat and their ability to survive the environment. But it's mostly different kinds of metals.
Awesome. All right, Miss Hewitt's class. Let's head to Burlington. You guys have a question? Go for it.
Okay, Kitty.
How many days did it take to orbit like the sun for like about
What's a year on Mars?
Yeah.
What's a year on Mars? Awesome question.
Yeah, what's a year on Mars? So a year is one orbit around the sun. I don't know the exact number of Earth days, but it's something like 630 something. But roughly one Martian year is equivalent to 2 Earth years. So every time we go through 2 years, Mars, because it's further away, goes through 1 year.
Yeah. I want to do a quick follow-up on that to highlight Martian days versus Earth days, because I know it leads to some really interesting schedules for you guys.
Yeah, so that's the question I'm really aware of, is how long is a Mars day? That's important to me because the way we operate the rovers is we let them run on their own all day. And then at the end of the day, they send back all their data and we stay up the whole Martian night planning what we're going to do the next day. it gets confusing because the Martian day is just a little bit longer than the Earth day. Martian day is closer to 25 hours than 24 hours. So morning on Mars shifts by 1 hour relative to every Earth day. So, if we started playing at 9 a.m. one day, it's 10 a.m. the next day, 11 a.m. the next day. I'm pretty sure you're planning from at 2 in the morning. We call doing this living on Mars time. We did this for the first 3 months of the mission. We don't do it anymore because it's really hard to work on a 25-hour day schedule. So some days we'll plan 2 or 3 days at a time. And then there's also a very special name for a Martian day. We call it a sol. So we talk about a sol on Mars instead of a day on Mars.
So glad that got brought up. Thank you so much. Mr. Glass's group. Now your video's off, but I don't know if you guys still have audio going on.
Yeah, still have video.
Hey, Kendra. Welcome. Come on in.
So our question was, what is the favorite part of Abigail's job?
Ooh, no pressure. Favorite part?
Ooh.
Yeah.
I think I have 2 favorite parts of my job. Well, so many favorite parts. Okay. Yeah, 2 favorite parts of my job. First, I love looking at the downlink every day. Every day we're explorers and we see something new and we learn something new. And it is so fun to come in the morning and be like, what did the rover find yesterday? And to look at the data and a lot of the times what we find is totally surprising and it's not always exactly what we thought. And that is so fun. So I love that part of my job. Another part of my job that I didn't really talk about is that I get to think about, okay, well, what do we want to do next? What are the big science questions we have and what are the missions that we can send that would address those questions? What kind of measurements do you need to make to test those hypotheses that you have about, how things are happening in the solar system? And then, working with the engineers here at JPL to think about, well, how would I actually build something that could make those measurements and test that hypothesis? So that's really fun. I enjoy that part of my job a lot too.
I bet. All right, we got 2 more in the first round of questions, and then we'll do a whole other round as we're whipping through these. So Miss Vitito's class, if you guys want to come up, go for it.
How do you guys get the rovers to Mars without them burning up, leaving the atmosphere?
Yeah, how do we get them to Mars without them burning up? So when they leave Earth, we put them on a big rocket. And so the rocket protects them from all of the friction of the atmosphere when they're launching. When they get to Mars, it's hard. As I mentioned, Mars does have an atmosphere, and it's a really annoying atmosphere because it is thick enough that there are winds and there are weather, and it causes friction and heating, but it's too thin to actually slow you down enough with a parachute to land safely on the surface. So we need to do these crazy complicated mechanisms for landing these rovers on the surface that involve heat shields. So we have a heat shield, that's what protects you from the heating of the atmosphere when it's the most intense. We have parachutes that we deploy that can help slow us down a little bit once the heating has slowed down. But then to get to that last little bit to the ground, engineers here have invented all sorts of crazy mechanisms. So Spirit and Opportunity landed in what looked like this giant pyramid of airbags. So right before they got close to the surface, these big airbags inflated all around the rover, and they actually just bounced. They hit the surface really hard, and they just bounced and bounced and bounced for a really long time until they lost enough energy to settle down. Curiosity, it was too big for the airbags. The airbags would have popped. So instead, they used something called the sky crane, which are basically a series of retro rockets that they attached to the top of the rover. They lowered the rover down on the sky crane, and then they fired these rockets to slow it down right before it hit the ground, and then cut the cable connecting the rockets to the rover, had the rockets fly away and then land somewhere in the distance. And actually, it's kind of fun. In one of the first pictures that Curiosity sent back, like right after it landed, there's like a little bit of a smudge in the distance in the direction that the rockets landed. It could be a piece of dirt on the lens cap, but it also could be the explosion of the rockets having landed in the distance. And we know that there's a lot of extra fuel on there. So we'll never know what it is, but I always think that's kind of a fun story. And the next rover that we're going to send, that's how it's going to land as well, using that sky crane system.
Ooh, I didn't know we were reusing the sky crane. That's so exciting.
Yeah.
I love that if you would like come up with these in a Hollywood movie, they would have rejected it outright as being overly ridiculous, but that we actually ended up using it. So It's fantastic. Let's head to the grade 12 class. Ms. Digby's group, if you guys want to come up, and then we'll do a whole other round of questions. Go for it. You should be good, but your audio is not on. I don't know why. You're unmuted, but it's not working. So smack the computer. That's what I always do. There you go.
Is it working?
Yeah, you're good.
Okay. When do you think you'll be able to send humans up to Mars?
Oh, when are humans going to go to Mars? I get that question a lot. And my answer is always, I don't know. Hopefully soon, hopefully the next few decades. I think we have the technology and the capabilities to send humans to Mars right now. It just takes a lot of money. Well, we have the ability to develop the technologies to take humans to Mars, I should say. It would just take a lot of money and a big investment. And we haven't had that investment yet. But that's not to say we won't have that in the future. It's a question of whether investment to send humans to Mars will come from the government of the US. Hopefully it will be an international collaboration between many countries, and it's going to take a lot. Many governments around the world decide that this is something that they want to achieve and financially support it. There's also been a rise of industry. So people like SpaceX and Blue Origin and all sorts of companies that are working to build rockets that may find some success in also sending humans into space. And of course, SpaceX has the goal that they've stated that they want to send humans to Mars. So I think what it's going to take is a lot of money. But once someone does spend that money, I don't see why there's any reason we couldn't send humans to Mars.
It's a really exciting time to be interested in space exploration in general, and certainly for kids in these classes. Like you guys are the age to be going back to the moon, to Mars, etc. So it's,
absolutely. I think in your lifetime, we'll see humans on Mars.
Fantastic. Abigail, I want to make sure you have time for another round of questions with everyone.
Yeah, absolutely.
Perfect. Let's head back then to Mr. Smith's class. If you guys want to come back up, go for it.
Who asked? Someone is asking the question, what is your favorite planet? You're studying Mars. I'm sure you've done plenty of studying Earth. What is your favorite?
That's a really good question. You might think I would say Mars, but my actual favorite planet is Earth. I love this planet the most because it's where I live. Earth is such a special place, and it has this remarkable set of circumstances that allows me, you, all sorts of life to live and to thrive here. And I think that's so special and so important. And, I'll also put in my personal opinion. We have people who talk about, well, we're trashing the earth, there's climate change, all sorts of things are going wrong. But don't worry, we can send humans to Mars. That'll be our backup, our plan B. And I just want to tell them I think they're crazy. Because Mars is so much harder of a place to live. The atmosphere is so thin, and people have ideas about releasing the carbon dioxide in the Martian poles into the atmosphere to warm it and how we can make it work. It's so hard to do that. And Mars is in the state it wants to be in right now. It's what's called kind of its thermodynamic equilibrium. So why would you'd be fighting against that the whole time you were there? So I think Earth is such a wonderful place, and it's really up to us to do all we can to continue to make it a wonderful place for us and everybody to live.
I'm so happy you interjected with that, because it's something that we get in a lot of our space sessions now, is people going, oh, we could go to Mars. No matter what we do to the Earth, it will still be way more habitable than Mars would, and we don't have to send rockets to get there. So it's
right. I mean, go live in Antarctica, see how easy that is.
Right.
That's infinitely easier than living on Mars.
Yeah, fantastic, but still a fantastic planet, as we learned from your whole presentation. Yes. And, let's go to Ms. McDonough's class again. If you guys want to come back up, go for it.
You go first. Two-part question.
How do rovers stay on the ground on Mars?
And
how can rovers go smoothies on Mars rough terrain?
Oh, good question. Also, I love your Washington Nationals shirt. I'm a big Nats fan. I'm from the DC area. Anyway, yeah. So how do rovers stay on Mars? And how do they drive over rough terrain? So Mars, even though it's smaller than Earth, still has gravity. It has about the third the amount of gravity that Earth has. A 2-ton or 1-ton rover that weighs a ton on Earth still weighs quite a bit on Mars. So that's not too much of a problem. But how does it handle the rough terrain? Well, we actually have a very special suspension system designed for the rover. This is called a rocker bogie suspension system, and it actually allows the wheels to move independently of each other. So it can climb up and down really rough and rocky rocks, and the wheels can move all sorts of crazy directions, but the rover body itself stays relatively level. So it's a very special design that we use for the suspension system that allows us to travel over the really rocky and rugged terrain on Mars.
Outstanding. I love that model. Oh, quick follow-up question. What is the cool globe you have beside you?
Oh yeah, got this thing. It was upside down. So this is Mars. You might think it's a little bit weird because it's not red. Mars is usually red, but this is actually a topographic model of Mars. So the different colors here represent the height of the land. And you know, one of the big things you might notice, first of all, the top of Mars, this is the top, is mostly blue and the bottom is mostly red and yellow. Mars actually has kind of two parts. We call them the southern highlands. These are really high areas, and the northern lowlands. So it's a really cool dichotomy. Some people think there may have once been an ocean up here where it's blue. I'm not sure that's right, but it's an interesting thing to think about. Some other fun things, we have big impact basins in the bottom of the planet. This is where a giant impact that was really long time ago hit the planet. We have some pieces up here that they're so high that they're white. These are giant volcanoes. This in particular, this is Olympus Mons. This is the biggest volcano in the solar system. It's huge. It's bigger than Everest. We also have a big canyon that cuts across parts of Mars. That's called Valles Marineris. And if you put a map of the United States, or probably Canada too, it would actually stretch from one end of Valles Marineris to the other. So that's a huge, biggest canyon in the solar system as well. So it's a special place.
Very cool. Thank you so much. All right, let's head to Miss Hewitt's group. Come on back up, guys.
So how are you able to connect with the rover all the way from Earth when the rover's on Mars?
Yeah, so it takes a lot. So the rovers can talk directly to Earth. Usually what we have them do, though, is they actually talk to satellites that are orbiting Mars. And it's a lot easier for them to talk to the orbiting satellites. They can send a lot more information because it's a shorter distance. But then to get everything from Mars to Earth, NASA has a system that's used by ESA and JAXA and space agencies around the world, CSA, called the Deep Space Network. It has like a really Star Trek-y name, Deep Space Network. And what that is an array of giant radio telescopes that are located around the world that we use to talk to them. Some of them are up to 70 meters big, which I can't stretch that far, but they're huge. One of the Deep Space Network, or DSN, stations is located in California. One of them is in Spain, and then the third one is in Australia.
Outstanding. And so we will share, by the way, information about all this stuff after the fact as well, links to your work, links to NASA, anything you'd like to share with us too, you can send to me in the email, and we'll pass it along so classes can tune in and get excited about things and keep learning going.
Sure.
All right, Mr. Claessens, let's come back to you. Go for it. 3 more questions, guys, total.
If there really was water on Mars, what do you think?
Oh, could you come a little closer to the camera? We almost got that.
If there really was water on Mars, what do you think made it all evaporate?
Yeah.
Oh, that is an excellent question, and something that we are studying because we don't actually know the answer to that question. We think, at least the water that used to be on the surface, some of it is frozen and trapped in the poles. Some of it is frozen in ice and trapped underground. So some of it is sucked into the minerals that we see on the surface of Mars. And we think some of it was lost to space. And we think it had something to do with the fact that when Mars used to have a magnetic field like the Earth does, but it lost its magnetic field at some point in history. And when that happened, the protection kind of holding the atmosphere on disappeared. And at that point, particles from the sun could actually strip away the atmosphere. Mars also has less gravity, so pieces of the atmosphere are going to come off more easily than Earth. And a combination of those processes strips some of the water out of the atmosphere of Mars. We actually have a mission that's studying those processes right now. It's called the MAVEN mission, and it's looking very carefully at the interaction between the sun and the atmosphere of Mars and understanding how it's being lost today. And then we have data from the rovers that we can see what the atmosphere was like back at the time when the lakes were around, and we can see that it was definitely much thicker then. So it's some combination of those interactions that is the reason the water got lost. But there's a lot of details that we don't really understand. And that's why we like to study the planet, to learn these things, because it's a really interesting question.
Super cool. All right, we're going to wrap up with two last questions. I'm going to go to Ms. Robinson's first and then end off with Ms. Vitito's. So if you guys want to come, sorry, not Ms. Robinson, Ms. Digby. Hi, guys.
In your own opinion, what's the most interesting finding made by the Curiosity rover?
Oh, there's been so many. I think the findings about how the atmosphere have evolved have been really interesting. I think another really exciting discovery that we made was that within the lake sediments and these rocks that were deposited in a lake are organic molecules. So organic molecules, basically it's a way to describe any molecule that contains carbon. But they're exciting because they are the building blocks of life. They are things that life needs. You know, are these organic molecules body parts of ancient Martian life? Maybe, but they could also be from some other process. We know there's a lot of organic molecules on comets. They could have been delivered to the Martian surface from comets. They also might be some carbon in the mantle of Mars, and that's where the carbon came from. So we don't know. But we know all of the ingredients of the building blocks of life are there.
Awesome. That's, again, a hard thing to choose with such an amazing scientific mission. And it's so great that kids, like, it's such a neat thing and fairly unique that kids can follow along every day with what this mission is doing. Like, that is such an amazing thing that NASA provides. And so we'll pass, again, those resources when we're done so you can check it out and see what's going on. But let's end for now with Ms. Vitito's class. If you guys want to come up for one last question, go for it.
About how much money does it cost to make a rover?
Awesome. The cost question. I love it.
The money question. Yes. So Curiosity and the next rover that's going to Mars both cost about $2.5 billion to make. So that is a lot of money, but they're very special. You know, it takes a lot of work to build something that you're sure is going to operate in this very extreme environment on Mars, especially when if anything breaks, you can't go and fix it. You know, you can't call up a mechanic and say, hey, this wire fell off, can you put it back in? Because it's on Mars. So a lot of the cost is in engineering something so special that can survive in this environment. But, you know, in the grand scheme of things, it's shown us so much and we've learned so much. And so personally, I think that cost is worth it. I think all of NASA's budget, so that covers not only the rovers, but the other spacecraft mission, the astronauts, the space station, the Earth observing satellites, everything NASA does ends up costing every US taxpayer about 1/2 of 1 penny of every dollar they spend on their taxes. So in the scheme of things, it's not a huge amount of money, in my opinion, in terms of all of the money that the government spends. But up to you guys to decide what you think of that.
And again, you mentioned all the things it pays for, and I really love the money question when it comes to space, because I mean, you look at the developments and the exciting understanding of the solar system, the universe and beyond, and of the planet Earth based on what we've done in space. And so it's a really, if there's ever a worthwhile investment in science, it's the work that NASA and other space agencies around the world are doing. Thank you so much, Abigail. What a fantastic presentation as always. I know we could talk all day. But as you know, what we do at the end of every presentation, I'm going to demute everyone's microphones. And so boys and girls, if you guys get ready to join me in saying a huge thank you to Dr. Fraeman for joining us today, you are all now demuted. Go for it. Thank you so much. Thanks, guys, so much for joining in. We really appreciate you tuning in. And please do continue joining us for the rest of the month as we continue to highlight incredible women from around the globe. Dr. Fraeman, thank you so much again for joining us. We always love having you back here.
Oh, thank you so much for having me, and thank you all for your excellent questions.
Yeah, it was a really enriching, fulfilling session today. You guys are really on the ball. And again, check out those resources after the fact. Lots more to learn and keep the excitement going. So for now, have a